label your inlet and outlet, for this one, I label as F plus S equals to W plus P. F is the unpeeled potatoes, S is the steam, whereby W is waste stream, P is the peeled product, peeled potatoes. So it has been given from the problem statement, for every 100 kilograms of unpeeled potatoes, you have 4 kilograms. You need to use 4 kilograms of steam. So we have here 100 plus 4, okay, equals to these two unknown, W plus P. These two, we do not know what is the mass of these two products. Okay, so I've taken one of the unknown. For example, W is equals to 104 minus by P. So this one is the first equation. Then for the energy balance, this one is MCP delta T. But look here, this one MCP delta T for the unpeeled potatoes. This one SH, this one is meant for the steam. Steam, we have the M for the steam, but then the value given in the problem statement is the latent heat, the enthalpy for the steam, whereby it is CPT. Okay, so it is being represented by H, enthalpy. Alright, equals with the outlet. Outlet, this one we have for waste stream, and this one is the peeled potatoes. Okay, if you look here, we minus by 0. Okay, this temperature difference we minus by 0. Why is that? Because we take 0 degrees Celsius as reference temperature. And remember, just now I have mentioned to you, temperature difference, the value of temperature difference between degrees Celsius and Kelvin are at the same value. For example, if let's say I divide the value of 15 degrees Celsius minus by 5 degrees Celsius, I will get 10 degrees Celsius. When you convert the value of these two temperatures into Kelvin, you will still get the temperature difference as 10 Kelvin. Alright? So you can calculate on your own. For example, 15 degrees Celsius convert to Kelvin, whereby 15 degrees Celsius you need to add with 273.15 in order for you to get the temperature in Kelvin. 15 degrees Celsius minus by 5 degrees Celsius. 5 degrees Celsius convert to Kelvin. 5 plus 273.15. You will still get the temperature difference, delta T, as 10 degrees Celsius and 10 Kelvin. So from here, we take the reference temperature as 0 degrees Celsius or 0 degrees Celsius. Okay? If let's say you want to convert 0 degrees Celsius to Kelvin, there is no problem because 0 plus 273.15 is equivalent to 273.15. Right? Okay, so this one is the energy balance. So again, put up all the information, all the values that has been given in the problem statement. Okay, you will get this value 2690. 2690 plus 11,000 equals to 252W plus 122.5P. W and this P is unknown. This one is the mass. Okay, mass. This one is mass. This one is M. M. M for the waste stream, M for the peeled potatoes. Okay, so can you see we can solve this problem in simultaneous equation. 1 and this one is 2. Okay, this one you need to add. Please add on your own. 6290 plus 11,000. So you will get simply as 17,290. Okay, so this one substitute 1 in 2 because just now we have taken out W here. So W, put W here. Okay, so this one is W equals to 104 minus by P plus 122.5P. This one is the second equation. Alright, substitute equation 1 into equation number 2. W just now you replace with W in equation 2, this one, W in equation 2, you replace from equation number 1 over here. Because you want to calculate for first unknown, okay, for the P. When you calculate, you will be able to get 68.87 kilogram. Okay, P, this one P. Minus, you need to minus on your own. Alright, so this one I just cut it short for the calculation. So P, I will get 68.87 kilograms. This particular value, P value, you put into the first equation or second equation is totally up to you where you want to calculate it. But I prefer for you to put into equation 1 because it is simpler. Okay, put the value P that we have calculated just now, 68.87. 104 minus by 68.87, you will get W as 35.14. Do not forget the unit. We are calculating the mass for the products that going out from the system, the waste stream as well as the peeled potatoes. So the mass is in kilogram. Okay, basically this particular question, if it is given to you, the marks is normally around 10 if I'm not mistaken. Alright, so now let's move on to the following example. Okay, example 4, a casein dryer is found to consume 4 meter cubic per hour of natural gas with calorific value of 800 kilojoule per mole. If the throughput, this one is the system, okay, the continuous system of the dryer is 60 kilogram of wet casein per hour, it will dry the wet casein from 55% moisture to 10% moisture. Estimate the overall thermal efficiency of the dryer by taking into consideration the latent heat of evaporation is 2,257 kilojoule per kilogram. Again, latent heat of evaporation, this one is enthalpy, H. H is represented by Cp times by T. Okay, so now let's calculate this particular example. Let's solve this particular example. Okay, so from the information given, the wet casein that is in the system is 60 kilogram. Wet casein is 60 kilograms. Okay, it has moisture 55%. 55%. So out of 60 kilogram, 55% is water, and the rest 45% is the casein itself. Okay, so this one we calculate the moisture, then 60 minus by 33, this one is 33, okay, 45%, 60 times by 0.45, you will get 27 kilograms. So it's similar, 60 minus by 33, also you will get 27 kilogram of casein. Okay, that one represented by 45% out of 60 kilogram of wet casein. Okay, the 55% of wet casein is moisture. Alright, then we move on. For the final product, it contains only 10% of moisture. Okay, so 10% of moisture is coming from the casein itself. Alright, we remove the water. So from the casein, it only left with 10% moisture from this casein that we have calculated. So 10% moisture is 27 times by 10%. So the water inside the dry casein. Okay, if let's say you have a milk powder, although you can see the milk powder is dry, but it still contains moisture. So basically the moisture is around 5 to 7%. So for this particular example is 10%. So 2.7 kilogram, this one is water. Water that contained in the dry casein. Alright. So moisture is being removed. Okay, how much water has been removed? This one is moisture and this one is also moisture. Water, this one water, this one water. So 30.3 kilogram of water is being removed for every 1 hour. Alright, this one you just add per hour. This one is the water flow rate. Okay, the flow rate of the water is being removed, 30.3 kilograms per hour. Alright, and then given from the equation, latent heat of evaporation, H is 2257 kilojoule per kilogram. Alright, so this, what does it mean is whereby for every 1 kilogram of moisture, it can 1 kilogram of moisture to be removed, okay, it requires 2257 of kilojoule of heat. But we have 30.3 kilograms of water that need to be removed. Okay? So in order for us to remove, what is the amount of heat required to remove this 30.3 kilogram of water is 30.3 times by H. This one is M, this one is CPT. Alright, so you will get 6.8 times by 10 to the power of 4 kilojoule per hour. The amount of heat required to remove 30.3 kilograms of moisture from the wet casing. We want to achieve dry casing. Okay, and then we assume that the process is at constant, at the standard temperature as well as the pressure. So 1 mole will occupy 22.4 liter. Okay, rate of flow for natural gas is being given from the problem statement is 4 meter cubic per hour. Alright, 4 meter cubic per hour. 1 meter cubic, can you please add into your lecture notes? 1 meter cubic is equivalent to 1000 liter. Okay, so that's why you will get here meter cubic, suddenly you have 1000. Okay, this one is whereby we convert from meter cubic to become liter. So 1 meter cubic is equivalent to 1000 liter. So 4 times by 1000 liter per hour. Why do we want to use this liter? Because this one, we have this 22.4 liter occupy for 1 mole. Okay, so 22.4 liters, 1 mole occupy for 22.4 liters of gas. Okay, so if let's say I have 4000 liter of gas, what is the amount of mole? What is the value for the moles? Is 179. So for 4 meter cubic of 4 meter cubic per hour of gas, natural gas flow, we will have 179 moles per hour. Okay, so heat available from combustion, whereby it is equivalent to rate of flow of natural gas times by calorific value. Where do you get this 800, the calorific value? This one over here, with a calorific value 800 kilojoule per mole. Okay, so heat available from combustion, rate of flow of natural gas times by calorific value, 179 moles times by 800. Okay, from here, this one, the unit is moles per hour. This one is, what is this unit? Is kilojoule per mole. So we can cancel out for the mole. Okay, mole, so it left, the unit left is only kilojoule per hour. Okay, so the value is 14.3 times by 10 to the power of 4 kilojoule per hour. So how do you calculate the thermal efficiency of the dryer? Whereby heat needed divided by heat used. Heat needed by the equipment, okay, divided by heat is being used. Or heat needed, this one is heat that is being supplied. Okay, heat that is being supplied to the equipment. Right, heat being used. So the heat being supplied is 6.8 times by 10 to the power 4. Where do you get this value? Is from here. Okay, heat necessary to remove. This one we calculate, okay, by theory. This one is what actually is required. Okay, So the thermal efficiency of the dryer is only 48%. Alright? Clear? Okay, now let's move on to the following example. Example 5, pouches and canning. This will be the last example. A retort contains 250 pouches of beef curry. The pouches are heated to a temperature of 121 degrees Celsius. If the pouches are to be cooled to 32 degrees Celsius before leaving the retort, the specific heat are being given respectively. The weight of each pouch is 20 gram. Okay, and each pouch it contains 0.4 kilogram of beef curry. Assume that the heat content of the retort walls above 32 degrees Celsius is 1.8 times by 10 to the power 4 kilojoule. No heat loss. We assume that it is steady state condition. Okay, if 20 kilograms of cooling water enter at 15 degrees Celsius and leaves at 28 degrees Celsius, would this process successful? Would this process successful? Okay, what does it mean by this particular problem statement is whereby you need to calculate for the cooling water that is required to cool down the process. Basically, you need to answer, if let's say I supply 20 kilograms, is it sufficient for me to achieve food product cooling? How do you answer? Do you answer yes or no? You cannot answer because you need to calculate first what is the amount of cooling water required in order for you to achieve product cooling. Alright? So you need to calculate first what is the amount of cooling water, what is the mass of cooling water required to achieve product cooling. Then only you can answer, will this process successful if I use 20 kilograms of water? Yes or no? Depends on your calculation. You need to calculate first. Okay, so this 20 kilograms of cooling water, do not consider this value first. This one just to trick you. Okay, this particular value, 20 kilogram, is just to trick you. Okay, so datum temperature. Datum temperature is temperature reference, 32 degrees Celsius. Alright, so now let's calculate for the amount of heat required for every item. Okay, every item, we have pouch. Inside the pouch, we have meat. Okay, sorry, we have beef curry, not meat. We have beef curry. And then, what else? We have steam. We have water. Okay, 3 things that entering into the system. So, heat in pouches, pouch, MCP delta T. Alright, this one is 1 to 1 minus by 32. 32 is temperature, reference temperature. Do not take as 0 because it's already been given here. Datum temperature is 32 degrees Celsius. Alright. Weight of pouches. Okay, weight of pouches. What does it mean? We have 250 pouch into a retort. Okay, each pouch, the weight of each pouch is 20 gram. 20 gram, when you convert to kilogram, is 0.02 kilogram. And in the retort, you have 250 pouch. So what is the mass of the pouch alone? The pouch only is 250 times by 0.02. Okay, that one is mass for the pouch only. Okay, clear? Then you need to calculate for the beef curry. Beef curry is the content inside the pouch. Alright, you have 250 pouches of beef curry. Okay, so 250 times by what is the mass of beef curry in each pouch? It is 400. Alright, 0.4 kilogram. So you can see here 250 times by 0.4. This one is the mass. This value is the mass for the beef curry in the retort. Okay, times by Cp times by delta T. you will get the value of heat for beef curry, pouch content. Okay, and then for the water, okay, weight of H2O. We do not know what is the mass of cooling water required to cool down the temperature. Right? That is the trick of this particular question. 20 kilogram is not the amount of cooling water that is being supplied. 20 kilogram is to ask you, is to trick you. If let's say you just main teka-teka, okay, if let's say I put 20 kilograms, is it sufficient or not sufficient? I do not know. Okay, so you need to calculate. So mass of water we do not know, but specific heat as well as temperature difference, this one is already known from the problem statement. Okay, so you will get negative 71.162 W. Look here, W is unknown. This one is the mass of cooling water that we do not know. Okay, this one is meant for the product going into the system. And then you need to calculate for the product coming out from the system. Okay, again, you calculate MCP delta T. M for the pouch is 250 times by 0.02 times by its specific heat times by its temperature difference. Temperature difference because why it is 32 minus by 32? Because we want to achieve 32 degrees Celsius. When the product leaves from the retort, when it goes out from the retort, the temperature of the product should be 32 degrees Celsius. Alright? We do not want it to be higher or lower than that. It should be 32 degrees Celsius. And the datum temperature, the reference temperature is 32 degrees Celsius. So 32 minus by 32 is equivalent to 0. Okay? But in your calculation, you need to show this value. Okay? So this one is 0. Alright, and then another one is for the beef curry is the content in the pouch. Again, you need to show these values, how you calculate. Do not simply put as 0, 0, 0 because you already know. No, you need to write down what is the value that you managed to get this value of 0. How do you get this value of 0? Alright, so again, the same thing, 250 times by 0.4 times by specific heat times by temperature difference. Okay, and then for the Q of water, again, mass of water, we do not know what is the mass of water. Okay, times by specific heat times by temperature above datum. Okay, so W is unknown, mass of water is unknown. Okay, specific heat has been given, and then temperature for the water is being given in the problem statement as well. Okay, the final temperature of water is 28 minus by 32 is reference temperature. Okay, you will get as negative 16.744 W kilojoule. Okay, do not afraid with the value of negative, because negative meaning that the heat is going out from the system. The heat is being transferred from the hot item to cold item. Okay, so this one I group the value for the heat entering as well as for the heat leaving from the system. I group together so this one to ease your calculation. Okay, so this one we have heat in pouch. Okay, the beef curry, the retort wall. Okay, this one is being given. Okay, why this one is a 1.8 times by 10 to the power 4, but this one is 0? Because you need to look back in the problem statement whereby the enthalpy, the heat, the amount of heat for the retort wall above 32 degrees Celsius is 1.8 times by 10 to the power 4, whereby retort wall for the heat leaving, it should be at 32 degrees Celsius, meaning there is a no heat content for the retort wall. Alright, so plus this one, okay, calculate this one, total up. This one also you need to total up. Alright, and then use the same equation, heat enter input equals to output, total heat entering equivalent to total heat leaving from the system. Okay, this one what we have calculated just now, put it here. Okay, this one, put it over here. So you will get the unknown as W. Okay, calculate the W, you will get 1020.13 kilogram. But that is not your final answer yet. Your final answer, you should answer the question. If 20 kilograms is being used to cool down the product, will this process successful? Yes or no? The answer is no, because basically you need 1020 kilograms to achieve product cooling, not 20 kilograms. Okay, so basically this particular problem statement also will give you 10 marks, this type of problem statement. Alright, so with that, we have ended for chapter 3, and I hope you do your tutorial and please practice for the calculation in the example in your lecture notes as well as the tutorial. Please do it on your own and try to practice how to calculate, how to solve the problem. Right? We will discuss your tutorial and any related question that you may post to me later in our Google meeting later. Alright? With that, I thank you for your time, and please make sure that you sign up for your attendance after you have watched this